Okay, so let's start the class. So, you guys still can hear me, am I right?
Yeah.
So we are going to go back to finish what we talked about, asymptotic growth rate of the function. What is that? So I'm going to write some of the notes here, and then I explain everything again, so in more details and just more examples. So let's go to the definition. So I want to define some of the asymptotic growth rate of the function. So first of all, let's say, let g of n be a function So let's define O big O notation of g of n. How we define it based on what I explained yesterday. So what do we say about O of g of n? If anybody can have any idea about how we define it. Nobody?
It's the upper bound, right?
So we say, first of all, what is this f g of n? It depends on all of the functions f of n. Then there should be exist of c positive. And there should exist another n naught, which is going to be, that one should be positive too. And then what we are going to say, we say, okay, then for any n greater than equal to n naught, so I can say what I'm going to say here. So what was the definition? So you guys mentioned, we say f of n is going to be greater than equal to 0, greater than equal to cg of n. Probably I need to be a little smaller so it's going to fit. So n greater than equal to n naught, and then we are going to say, okay, this is going to be greater equal of f of n and c of g of n. This is a definition of big O notation. So it means that if I solve a problem and I couldn't find c positive or n naught after I solved it, I couldn't find n naught positive or c net positive, it means that this big O notation is not correct. It means that if I give you one example and say, oh, this is the problem and this is the result, and then you see you cannot find this c positive or n naught positive, it means that it doesn't exist. So what we say overall, if I have these things, we say that f of n is big O of g of n. So then this is equal to say that g of n is an asymptotic upper bound, because based on this equation, as you can see, it's upper bound of f of n. Does it make sense? Okay, let's see. If I want to show this one, how do I show this? I say, okay, let's consider this, for example, this line, BC of Gn. Then I can say that this is gonna be, for example, exact. Here. So this is gonna be f of n. This is gonna be like n. And as you can see here, from this point onwards, for example, this is n naught. So c of g of n is c of g of n is going to be upper, but g of n is going to be upper bound for f of n. Does it make sense? Let's go to the next one. Okay, so I explained here. So how this is gonna work, as you can see, this is is there any other definition that we can generate based on what we are gonna have here? As you can see here, this is this one. Based on this function definition, is there any way that we can find equivalently another definition? Does anybody have any idea? Is there any other way to define it? As I explained earlier, instead of just solving this problem, maybe I can find, if I give you a question, I can see if this C exists or not. So let's see, is there any other way to define this? Okay, I can say equivalently. So what's going to happen, instead of that definition, I can say there exists C positive and there exists and not gonna be positive 2, such that for any n greater than equal to n naught, so definition is gonna change. What is gonna be? It's gonna be f of n divided by g of n is gonna be between 0 and C. This is another way to define it. Instead of like, if I give you a question, so you have f of n and you have g of n, you will find this C and show that C is positive, because based on definition, C should be positive. So, and if I want to do the plot again, what's going to happen here? So I have n, and then I have this line, which is going to be line C, and then I can plot it like that. So, okay, this is going to be this is going to be this fraction f of n divided by g of n. So it means that after this is going to be n naught. For any n greater than naught, as you can see, this fraction is going to be less than C. This is another definition. This is another way to define this asymptotic stability, asymptotic notation of big O. Does it make sense? Anybody has any question up to now? Okay. If you don't have any question, let's see. Let's go and define a few functions. So, for example, what is the definition of the function f? We say it's going to be asymptotically non-negative, which we defined with A and N, which is going to be asymptotic non-negative, if and only if this is we can find there exists a n naught for any n naught greater than 0, and then for any a n greater for any n greater than n naught. So what's going to happen is going to say f of n is greater than equal to 0. So that's the definition of non-positive, asymptotic non-negative, asymptotic non-negative. Does it make sense? I think probably you've seen it in the past. This is the first definition. So no, yes, exactly. C shouldn't be that big, because if that big, there is no upper bound. You need to find that upper bound for that fraction. So if it's go to infinity, it means that you cannot find that upper bound. Yes. So let's go. This is the definition of that asymptotic non-negative. So let's see how we define that. There is another definition. So I say I want to define another. So if I ask you, how do you define positive? Fn is asymptotically positive. So which we define with A dot P. Anybody knows? So how do you define this one? It's going to be, we say this one is going to be if and only if what? Based on what I have the previous page. So how do you define it? Anybody? Is it hard?
Yes.
So it's, let's see. I say, okay, there exists, it means that there exists N naught is going to be similar, which is going to be a positive number, which is going to be, sorry, positive. And then what else? It said there exists for any N is greater than equal to N naught, and then f of N is going to be greater than 0. That's it, because it's going to be positive. The definition is going to be the same. Here it's a non-negative because we can consider 0. And here we just consider being positive, which is going to be f of N greater than 0. That's it. Does it make sense?
Yes.
Okay. So probably we say assumption. I consider assumption like blanket assumption here in the class. It's like blanket assumption that we have. We consider all function we discuss under discussion that we have are A, N, N. What does that mean? So I just explained. It means all the function that I'm considering is gonna be asymptotically non-negative. It means that for any N, after a while, it's gonna be positive. This function is not gonna be negative. That's it. You said that function is gonna be greater than equal to 0. That's it. It's not gonna be negative. Does it make sense? So let's see. I explained another example yesterday. So let's see. Example that we are going to have. We say we are going to show, okay, 10n plus 100. I want to find the big O notation. So I can say equal. This is going to be definition of big O. So I can say y. O of n squared minus 40n plus 500. This is one of the things that I mentioned yesterday. So second, the upper bound for this function is going to be this function. So it means that we have this upper bound, which is going to be the big O notation. So let me write it as a bigger O. So it's going to be big O notation. So, but as I explained earlier, this equals, it doesn't mean that only equal. It means that it belongs to, it's going to be subset of. It's going to belong to this function. It means all, if this function is going to be upper bound of this. So, but why? Anybody knows why? Why I say this one going to be happen? Why? Why that's the reason. What I can do. So if I want to say, how do you define like, what was the definition of the big O notation? Let's go back here. The definition of its big O notation, it means that I will need to find C and N naught, which this is going to happen. It means f of N is going to be between these two, up between 0 and the upper bound with C, G of N. So let's see. I want to go and try it here. So what was the problem? So, okay, I say F. What is this F? F is going to be 10n plus 100. So let's write it. So, okay. F is 10n plus 100. Based on the definition, it's going to be greater than 0 and it's going to be less than. So And let's consider C to be equal to 1, which is going to be n squared minus 40n plus 50. Plus 500, sorry. It's 500, okay. So let's see. I consider this is the equation. That was is f of n. This one is g of n. And I consider C equal to 1. Let's see if it's going to be considered, because if I found, I found C, I need to find n naught. If I found n naught, it's going to be done. What I can do, one of the ways just plotting them. So I plot this. I plot this one. So this is going to be like, this is, let's see. This is going to be g of n, because this is going to be like a square quadratic function. And then let's do this linear, which is going to be the line. So I will do this one. This is going to be like f of n. As you can see, I consider this one is asymptotic positive. It means f of n is not going to be negative, or g of n is never going to be negative. We just consider being positive, greater than equal to 0. So let's see. If I find this now position, this point is going to be 10. This point is going to be 40. It means after 40, every time g of n is going to be greater than equal to f of n is going to be the g of n is going to be upper bound for f of n. So what is going to be found? It means if I consider n naught to be 40 for any n after 40, this is going to be case. So then we consider n naught to be 40 and c equal to 1. So I found this equation to be whole. So it means that this is the big O notation of that. This is going to happen. So I say, okay, 10n plus 100, the big O notation of n squared minus 4n is big notation of this like 10n plus 100. Does it make sense?
Yeah, makes sense.
Okay.
How did you get C again?
I consider to be, like you can suppose, you could just suppose C is equal to 1. If I can find n naught, so that's great. I can consider C equal to 2, do this plot, and then I will find another n naught. If you consider C equal to 2, probably you will find n naught to be another value, maybe 80, something like that, you know? You can try, you can plot them actually, just put C equal to 2 and see where is they are going to hit each other, and then you can find another n naught. Probably it's not going to be 40, but it's going to be another number. Does it make sense?
Yeah. So where do you plug it into the n node?
Yes, I plug it here. So I just put it in the equation. If I put C equal to 2, I need to multiply it by 2 and then plot both of them, this one and that one. And then based on the plot position at the point that everything is going to be lower bounded with this one. So upper bounded G of n is going to be this part. So I can find n naught.
Okay, thank you.
Yeah. So let's see. There is one actually, there is a like theorem that we can say. We can say, in fact, based on this example, I can say, in fact, any linear function, which is going to be an plus b, any function. Here we have 10n plus 100. This is going to be big O notation of this function. It's going to be cn squared plus dn plus e. So this means that any linear function, the big O notation of any linear function is going to be like quadratic function. So it's going to be like this equation. So it means that any A, B, C, D, and E with A greater than 0 and C greater than 0. It means any equation that I give you, so any of these, if I have A positive, C positive, this is going to be whole. You can consider B, D, E, any numbers. So let's have another example. For example, I can say, for example, 60 n plus 100. The big O notation of this is gonna be 2n squared plus 10 plus 1000. Or maybe minus 1000. This is gonna be whole. Because this is the linear function, as I explained, A is positive, C is positive. Other than that, any other numbers like, oh my gosh. So any other number, which is gonna be B, D, and E, gonna be anything, can be positive, can be negative. Does it make sense? Is it clear?
Yes.
So there's another one. There's another term that I can consider. So, okay, also what I'm gonna say, I say, okay, P of n, let's consider P of n. So the big O notation of P of n is gonna be Q of n whenever Pn and Qn are polynomial. Let's see. Polynomial with how it works. So, okay, it's gonna be degree of, if the degree of P of n is less than equal to degree of Q of n. So it means it doesn't need to be n equal linear or Q be linear. Any other thing, the degree, let's see, for example, what's going on. So here, I'm gonna have one question. Is this equation correct or not? I have this. So let's consider that n squared plus 2n, is this one correct or not? This is the question.
Yeah, right. It's correct.
Yeah.
Why it's correct?
Because n squared plus 2n is underneath the bound of big O of n to the fourth. Like if you graph it, n squared, the quadratic is always going to be underneath like n to the fourth since big O is the upper bound.
Yeah, exactly. But I defined the like a theorem here for you guys. It's like a P of n, which is gonna be this one, n squared plus 2n. So this is gonna be the P of n. It's gonna be Q of n. Q of n is gonna be the second one. They are polynomials, so it means that anything like the polynomial order, so you can do both of them are polynomial, and then like take the degree. Okay, degree of this P of n here, because this is gonna be the maximum of this one. Degree of this one is gonna be 2. Degree of this one gonna be 2, and degree of this one, because the highest is gonna be 4. It means this degree is less than or equal to the other. So it means this is gonna be upper bounded by n power of 4. So that's the reason. So that's one of the examples. You can play with that one. I can put this one, I don't know. If I put this one to be 3, exact same thing is gonna happen. Does it make sense?
Yes.
Let's do another one actually. So how about this one? Is this one correct or not?
Nah.
Why?
Same reason with the other one.
So,
Big O is an upper bound.
yeah, let's see.
Yeah.
This is P of n, this is Q of n. So they're like, is this the degree of this one? degree of P of n should be less than equal the degree of Q of n. So the degree is coming from the max. So, okay, degree of this one is 4. Degree of this one is n squared, is gonna be 2. This is not gonna hold. So that's the reason this is not gonna work. So we say, okay, this is not be as you plot it. So if you do plot, yeah, for sure. And then it's easier. You look at this one, it's like, okay, this is not gonna be upper bounded, so it's not gonna be correct. Does it make sense?
Yes.
Yes.
Let's go to the, okay, I did define the big O notation. So let's go to the big omega notation. Let's go and just learn about that one. We explained about this one. So look at definition of like, I talk about big omega. So what is that word? So we said big omega of G of n is gonna be all f of n again, such that there is this C positive, and there exists like n naught, and for any n greater than equal to n naught, what's going to happen? So this time we say, okay, C G of n is lower bound for f of n. That's the definition of like big omega. We say what we say f of n is big omega of G of n. Again, there is another definition. What we say G of n, this is equal to G of n is an asymptotic, just write it like this, asymptotic lower bound. So how do we write it? We say, okay, f of n is this is equal to f of n is like equal to big omega of G of n. Again, when I define this one, what does that mean? It means f of n belongs to omega of G of n. Okay, this is the definition. Does it make sense? Okay, let's go here. So find the equivalence. We talk about this one for the other one. How about this one? As I explained, let me draw this first. So this is gonna be how is gonna define this one again. This time we say, okay, let's consider this one to be C of Gn. And then what we are gonna have like something like this, for example. This is gonna be f of n. So this is gonna be from this point onwards and not. So every C of G of n is gonna be lower bound for this. Does it make sense?
Yeah.
So let's go to find the equivalent actually. So, okay. Equivalently, so if I wanna be like definition what we have, does anybody can tell me how was the definition of this one? You remember what we did in the past, what we do for this one? For n greater than n naught, what's going to happen? How do you define this one? You remember if I go back here, so I defined, for example, for this one, you remember how I defined it? Now how we define this one for this example actually? What do we do? Anybody has any idea from based on this definition? Like this one. So this time what we do exact same thing. We divide by G of n again. So it's like, this one is 0. C is like, this one is going to be f of n divided by G of n. Exact same things. You have this inequality here. Just divide by G of n. It's going to be C greater than 0, f of n divided by g of n. So you're going to have this definition. So if you plot it again, so probably this is going to be the way. So you have n here. This is going to be C. And this is going to be your function. So this is going to be this. What you are going to have, you're going to have a position from n naught onward. That's going to happen. Does it make sense?
Yeah.
Okay. So there are a few things that I explained yesterday, which is really important. You can see this one in the in the other homeworks and the other thing. There is a theorem which is really important. What we say f of n is big O notation of g of n. So, and then we have an if and only if. It means that we say if and only if g of n is big omega of f of n. This is two-way. Both sides works. It means if I know f of n is like big O notation of g of n. So f of n is big O notation of g of n. I can say that g of n is big omega of f of n. This is gonna be the two roads. So both of them gonna work from this side to another. Let's write it like this. So you say if and only if, it means both sides of this equation work. Why? Go back here, look at this plot, for example. If I think about like g of n, f of n is going to be the upper bound for g of n. So consider c equal to be v1. So it means that f of n is upper bound. So if I have this example, so it means that f of n is going to be big omega of g of n. It means that g of n is going to be the big omega, O of the f of n. So it means it's going to be like this. This is going to be the difference you can see because of the upper bound or lower bound. Because one of them all the time is going to be upper bound. The other one is going to be lower bound. Does it make sense? Does it make sense? It doesn't make sense? I don't know if that is yes or no. I'm not sure. Is it coming from right now? Do you understand what's going on? Let's prove it. Let me write a proof. How it works. Then maybe it's easier. Okay, let's go back and based on definition, suppose what I say go f of n is big O of g of n. What does that mean? Does anybody can tell me what does that mean? Anybody have any idea? So first of all, let's go. When I give you this kind of question, look at the definition. Look at the definition. This is a definition. Am I right? This is coming from the definition. Let's see. Based on definition, what we say if this is the f of n is big O of the g of n, it means that there exists two positive numbers. One of them is considered to be C1, and the other going to be N1, which we talk about N naught, or we can consider N1. Such that how it's going to work? Based on definition, we say for any n greater than N1, thinks that N1 is N naught. So this is the definition. We can look at the definition. F of n is going to be greater than 0, less than C1 Gn. Does anybody have any question about this one? This is the exact same definition of like being a big O of n.
No, I think we're good.
Yeah, we are good. Okay, let's see. If I want to show the big O, this is the big O notation. If I want to show this one, I know I do have this one. I want to show this one. I want to show that G of n is big omega of f of n. How I want to show this one? If I want to show big omega, which is what I said, we must show that there exists. What exists? So positive, again, we need positive C2 and N2 such that. Let's go to the definition of like the big omega. So what was the big omega definition? So what's this one? So there exists the N naught and C, which is what's here, C positive. This is the equation gonna be considered. So if I want to show this one, what I'm gonna say, I say, okay, if I want to show there should be N greater than equal to N2 and 0, okay. What was the definition? We say, okay, this time G of n is here and C2 f of n is going to be greater than 0. Why? Because this is the example. Let's take of this one. F of n, G of n is big omega of f of n. I wrote it like this. G of n is going to be big omega of f of n. So how can I get from here, from this, how can I get to, let's see. Okay, from this one, from this red one, how can I get to this one? Anybody has any? Let's see, let's write them together. So I have this one. This is the definition of big O. And then I have this one. From the first one, how can I get to the second? The C1, actually. Anybody know how we can get from the first one to the second one? It's easy. Just consider, like, if I divide this one by, if I divide this whole, like this one, this second part, whole divide by C2. So C2 is greater than 0. It means that you don't need to just, or you divide it by C1. That doesn't matter, any of this. If I divide this one by C2, this is going to be C2. This is going to be gone. And this one is going to be 1 over C2. It means that C1 is equal to 1 over C2, or I can say C2 is equal to 1 over C1. It means, for just proving, if I consider C to be this one and N2 is equal to N1, because they are exact same, from one position to another is going to be this one, then I can prove that from A, I can reach out to B, and the proof is complete. Because the first one, this one was A, this part was A1, and then the second part here that we had is going to be part 2. From 1, we reach to 2. Does it make sense? Anybody has any question? Is this clear?
It's hard to tell without being able to see it all at once. All I can see is just like this one line, basically. So it's hard to really put it all together.
So this is because if I make it smaller, it's harder. So probably if I can write it smaller, but that's the best thing I can do. So
can you post this too?
I will post this one. Yeah, I will post this. This is going to be part of the class. So anytime we finish one of this present class, I will post it. Okay. I will try to next time to write it smaller, so it's going to be in one page, easier to understand. Does it make sense? Okay. Let's go to the definition, another definition. So how do you define theta of G of n? I teach this one another previous time. How do you define the theta of G of n? Anybody? Still, we say f of n is gonna be for all again. Exists C1 greater than 0, C2 greater than 0, and not greater than 0, and for any n greater than equal to and not. So what is going to be the equation? It's going to be C1 G1 is f of n. So what's going to happen? So f of n is going to be between C1 G1 greater than 0 and C2 Gn. This is the definition. Does it make sense? I explained this one earlier. So what we say, if you want to divide this one, we say that then f of n is big theta of G of n. And then what the other example is going to be G of n is tight. We say it's going to be tight, asymptotic, bound. Because it's going to be like a sandwich between both of them if I want to consider this one. So probably let's try it again. So this is going to be, we say f of n is equal to theta of G of n. So let's draw them again. So it's like, this is going to be like, let's see. This is gonna be f of n. And then what I'm gonna have, so let's, sorry, just make it a little more. And then we have this one as like C of C1 Gn. And then another one here, C2 Gn. It means after a while, which is going to be here after this n naught, this f of n is going to be between this C1 Gn and C2 Gn. Does it make sense?
Yeah.
Okay. So, but does anybody know what does this give you actually? So what does theta of G of n means actually? So let's see. Does anybody have any idea? If you want to consider like big O notation and big O, big omega notation, what does that give you? So probably let's skip this C to G of n. If you look at f of n, this green and this red one down, what do you see? What does that give you? The first one, this is the green one, and C2G of n, because C2G of n is upper bound for F1. Upper bound give me what? Upper bound give me big O. I say, okay, this is the big O of G of n. And then I do have the other one. I can see G of n is lower bound for F of n. Then what does that mean? If I have lower bound, it means that I have big omega. So it's going to be between, because it has both of them, it's going to be the intersection of both of them. Because I just look at any plot separately. This part, the first part here, this part, because C of n is lower bound, so it's gonna give us the omega, and this part, the other part above, because it's gonna be upper bound, it's gonna wanna give me big O. So it means that theta of G of n is the intersection between big O notation and big omega notation. Does it make sense? Okay, let's go back. You remember all these times, every time I just explain, I just found the equivalent definition. So what is the equivalent definition for big theta? So how do you define this one? This time, I think you guys probably should know this one. What is the equivalent? So probably for any n greater than n naught. How do you define? Look at this definition. Find the equivalent for that. Anybody has any idea? Nobody? Don't be shy if it's fine that it's not right. So just to see what is your idea. Nobody?
Wait, what's the question?
So what is the equivalent of this line? So here, if I want to define other way, how do I define it? I explained earlier. So for example, equivalent, instead of finding this inequality, you can do another thing. So what was the other thing? The equivalent of this definition. As I explained, so what you can do, instead of just going here and just find this equation, what I can do, I can divide everything by G of n, because G of n is asymptotically positive. So what is going to be, so if I divide everything by G of n, what's going to happen? So I divide everything by G of n, it means, because at the end of the day, for proving that is correct or not, you need to find n naught, C1 and C2, that's it. So if I divide every part of that equation by G of n, this becomes C2, this becomes C1, and this is going to become greater than 0. Let's go here. I divide this one by G of n, so it's become f of n divided by G of n. G of n is going to be removed from this one. This is going to be C2, this one is going to be C1, and it's going to be 0. So that's the definition of the equivalent. It means instead of going and showing that one, if I give you an example, let me see right like that. For example, I write that, okay. Example. I ask, okay, is N4 is going to be big theta of N5? I ask this question. So you already have f of n. You already have g of n. Instead of just going and showing, what you can do, you can divide these two and see if there is any C1 and C2 that gonna bound this one and can be true. So what does that mean? It means if I plot this one, if I plot it, let's see. It means I have one C1, C2 here, another number C1, and then if I plot this, like N4 divided by N5, what's going to happen? If I plot it, for example, it's going to be something like this. It means after a naught here, this f of n divided by g of n is going to be between C1 and C2 every time. So That's the definition. So that's going to be an equivalent. Instead of just going and showing this is problem, this is going to be correct. What you can do, you can divide it and show that there is C1 and C2, which is going to work. That's another way to prove it. Does it make sense?
Can you go back to the equivalent of what you just wrote down right here?
Yeah. Mhm.
Not this one, but the one you showed before it.
Okay, is this one.
Thank you.
Oh, so this is going to be f of n is between C of G of n and C to G of n. You just divide it by G of n. Instead of proving this one, you can prove this one. This is the equivalent. It means they are going to be similar. Is it clear?
Can you go back again, please?
Mhm.
Okay, I'm good. Thank you.
You're welcome. So let's solve the problem together. So one of the things that we can prove, there is like we want to prove like this holds law. Let's see. So let's go back. Let's solve this problem. So okay. But eventually, if I want to calculate and show this big O notation and everything, if it gets harder and harder, if I like, for example, different example, probably it's maybe harder to just write based on this. Let's see. Probably I can make it smaller. So you guys, is it better? Probably if it's become smaller, it's easier to see. How about right now? So is it better?
That's better.
I'm so sorry. I think I should have started from. Okay, now we have it all on one page. Maybe it's easier to see. Okay. No, but so that's the definition of another definition. So let's see that there is another definition for big O annotation. So we are trying to see how we can solve this one. So how we can solve this big O notation, so definition of the smaller omega, big omega, and show all of them. So there is one thing that we need to show. Although we have big O notation, big O, we have a small o too. So there is a definition of the small o, so not big O. So let's go back to definition. If we have a definition of the a small o G of n. So what is this definition? If I want to have definition, f of n of a small G of n, the definition is like this. You say, we may take a limit. It means it's going to be, f of n is going to be a small o of G of n, if and only if I have only f of n divide by G of n, if I get n is go to infinity, this goes to 0. This is the definition of what a small O notation. So it means that if I have this, if I consider f of n divide by G of n, and if I consider n go to infinity, if this goes to 0, it means I have this one. So probably let's do this one. What does that mean? So if I have this plot, so we have C, you remember, we say C is this one, that number. So what I'm gonna say is if I do this division, so it means after a while, this is gonna go to 0. So it means this one is gonna be f of n divided by G. If I go back, so let's go back to big O notation. So probably where is big O notation? So it was here. In big O notation, I say if I divide f of n by G of n, there is a C that f of n divided by G of n is gonna be less than that C. This is gonna be definition of big O notation. For a small O notation, still it's going to be less than c, but when n goes to infinity, this goes to 0, although it's smaller than c, but eventually when n goes to infinity, this becomes smaller, it's going to become 0. Does it make sense? Is it clear? Okay.
So is it like lower?
What?
Is this lower bound?
Yes, it means that definition of this one, it means that after a while, it's going to go to, although this is going to be small, but it's going to be less than c, but eventually n become bigger and bigger, it's going to go to 0. Let me solve an example here, actually. Let's explain one example here. So makes it easier for, this is going to be some of the proof that you need in future. Let me show you some, for example, one example here. So probably makes life easier for you guys. Let's see if I can find one example to show. Okay. Okay, let's see. Let's solve this one. Okay, let's see if I want to write this example. So I have a question. So because n factorial, so it's going to be a small of n power of n. Is it true or not? I have give one as a question to you guys. I say, okay, prove this one. Is this a small o notation? Is it correct or not? How we get approved? How we do that? We say, if you ask me about a small o notation, what I'm going to do, I'm going to divide f of n by g of n, get this limitation. If it goes to n goes to infinity, if it becomes 0, it's done. It means this is correct. This equation is correct. It means n factorial is going to be a small n of n power n. Does it make sense?
Yes.
Okay, so let's see. There is a string for formulation. So what we say about like this, there is a definition for n factorial. So there is the name of this n factorial definition, because n factorial of n like power of n, they are different. If I, for example, if I write this one, f of n divided by g of n is going to be n factorial divided by n power of n. If you do limitation, you don't know how to calculate, but there is a formulation which names Esther. So let's see. The formulation is this one. Stirling's formula. A Stirling formula says n factorial is equal to square root of 2 pi n, then n over e to the n, 1 plus theta of 1 over n. So that is the definition. So that's one of the definition. There is a, this is the whole definition of this one. There is a like, we have another like weaker version of that, weaker version. In weaker version, what we say n factorial is probably equal, like approximately equal to, like having this one, 2 pi n over e power of n. So you have this one. What I can do, I can just what we did, but we say, okay, get the limits of what? N factorial divided by n over n. N goes to infinity. Find this one. If it's equal to 0, great. We proved it. If it's not equal to 0, it means that that was not true. So instead of n factorial, let's put this one. Let's put this weaker version. So it's going to be 2 pi n and then n over e to the n. So I put this one, and for this is gonna be n over n. Does it make sense? And then n goes to infinity. So then we use that. Actually, let's use this weaker, better, like a strong version. So it's gonna put this one here, 1 plus theta of 1 over n. Okay. So if I put this one, this is gonna be cancel out with this one. This is gonna cancel out with this n.
Professor,
Hmm.
someone's asking a question in the chat.
Okay, so let's see. Yeah, this is a definition about big O notation. Big, yeah, a smaller notation is a little different, yes. Because it's a strictly less than, yes. But it's go to infinity. When it's go to infinity, it's become a small, yes, that's correct. So, but now let's see. If I just prove this one, there is one n here. There's one here. If I just do, this is going to be n like a square. So this is going to be this one. So this is going to be equal to 1 over n over 1 over 2. This is going to be n. If n goes to infinity, it's going to be 1 divided by infinity. It goes to 0. So probably just if we calculate this one, it shows that this one is go to 0. So we showed that this is going to be a small o of n of that part. So we showed this is going to be correct. So we just showed this is correct. N factorial is going to be a small o notation of n power of n. We just show this one. It means that for just probably just wanna show any example, you just show this one. You find the limits of this f of n over g of n. N goes to infinity, becomes 0. So that's it. Does it make sense? Okay, so yes, that's probably one of the easiest one to calculate. If I give you homework, so you just do this like calculation and figure it out, is it correct or not. Let's do another one. Let's do one really simple one, maybe more simpler version than this one. So anybody has any question? I hear one person talking. Mute. Okay, so let's do one. Just give you 5 minutes to figure it out. If is it okay? Is it correct or not?
Yes.
How do you prove it? Let's use, this is a small o notation. This is not a big O notation. This is a small O notation. How do you do this if you want to prove it? What is the way? Okay. Yes. Okay. Let's see. First of all, this is going to be f of n. This is going to be g of n. What I'm going to do, I divide n4 by n7, and I'm going to get the limit. Sorry. Okay, let's write it again. So it's okay. N4 divide by n7, get the limit, and goes to infinity. So this is going to be limit of 1 over n cubed and goes to infinity. It means this is going to be 1 over infinity. It's going to be equal to 0. So it means it's correct. Does it make sense? Did you guys understand what's going on?
Yes.
Okay. I will upload some of these like mass functions, some of this definition just as a PDF, so you guys have some idea about what's going on. For example, maybe if you forgot some of these actually, so some of the like factorials, if you use like other example like ceiling, floors, so that's going to be useful when you know it. So you need to know these concepts before just going to another problem. Okay. Okay, so just give you guys like 5 minutes break. So we will continue on like definition of this big O notation, some of this exam.
Does that say N to S in the bottom left? Or-
N3, 4/7 is become N3.
no, I'm talking about the
It's
bottom
to
left.
infinity.
Oh, to
Okay.
infinity.
Yes, it's go to infinity.
Okay, thanks.
Yeah, because this is, oh my gosh. Definition of go to infinity. So this is become 0. If it's become 0, it means that we are done. Just, does anybody have any question? If you have any questions, so please ask. If not, just you guys can have a break for 5 minutes. So I keep going on the definition of the smaller and then ON. So, and then we can explain some definition.
So how did you get N to the 4th power over N over to the 7th power to equal to limit 1 over N to cubed?
So this is for, that's what you can do. You can say like is multiple N minus 4. This is
Mhm.
multiple N minus 4. This is become 0. N to the 0 is become 1. And this one 4 minus 4, 7 minus 4 is becomes 3.
Oh, okay, makes sense.
Yeah, did you get it?
Yeah, I understand now.
Okay. So probably so. I will respond to your email. Probably this is going to be at the end of the June. So, but I will check. So let's write the definition of the small o of g of n too. So it's going to be all the f of n that exists c greater than 0 and not greater than 0 for any n greater than n naught, equal greater than n naught. So this is going to be definition. It's going to be f of n is greater than equal to 0, less than. It means that previous time was less than equal. This one is going to be less than, and this is going to be c of g of n. It's the exact same thing that we have, but this one is good. It's going to be like a small, less than equal. And then what we say g of n is a strict. Because it's a strict, it doesn't have equal. It's a strict asymptotic upper bound. Previous time it doesn't have a strict because it was like equal, but this time we don't have equal, we have, so it's going to be a strict upper bound. Does it make sense? Is it clear?
Yes.
Let's talk about a small omega n. So we talk about exact same thing. If you just remove this equal, it's going to be a strict. So we are going to have another things. So there is a definition about a smaller omega. So what is the definition? Again, we say for all f of n such that there exists c greater than 0, exists n naught greater than 0, and for any n greater than equal to n naught, so that's going to be c. It's going to be gn, oh, sorry. So cgn greater than equal to 0, but this time is going to be less than f of n. It means f of n is not going to be equal. That's it. And then this time we say f of n is equal to a small omega g of n. And we say g of n here is a strict asymptotic lower bound. Previous time this we have equal here. This time we don't have equal, so it's going to be lower bound. Does it make sense? So let's write them together. Let's write them together. So probably let's do something. Okay, if I write definition of big omega, so let's write definition of big omega. What was the definition of big omega? It's going to be f of n such that there exists c greater than 0, again, n not greater than 0, and then for any n greater than equal to n naught, we say this one, g of n, c g of n is greater than 0, less than equal to f of n. This is the definition of big omega. But if we go here, this is the definition of the small omega. As you can see, a small omega doesn't have equal. Big omega has the equal. They're exact same thing, but the only things that we have different, there is equal. So what it shows us, it means that a small omega g of n is going to be subset of the big omega of g of n, because they're exact same thing. This one has one equal that this one doesn't have. So this is going to say that a small omega g of n is going to be subset of the big omega g of n. Does it make sense?
Yes.
And let's see, we say for a small omega, as you can see, for a small o, what we have for a small o, after a while, this division, f of n divided by g of n, go to 0. If you come here, let's go back to this definition. So if I divide for this big, like a small omega, so if I divide g of n by f of n, So f of n by g of n, if I still divide f of n by g of n, it means it's greater than c. It's really greater than c. So we can talk about going to infinity. So here we start is c and say, okay, after a while, this is going to get bigger and bigger than c, which is going to be f of n or divided by g of n. So now we can define another way to just find this small omega. What we say if f of n is a small omega of g of n, if and only if this limit of f of n divided by g of n goes to infinity, become infinity. It's become bigger and bigger and bigger. As you can see in this photo, it goes to infinity. It's going to get bigger and bigger. So probably if we divide f of n by g of n and go to infinity, become infinity, it means you have a small omega. If this one becomes 0, it means you have a small O notation. So this is going to be the definition. There are two things. So one of them is going to be, if it's go to 0, it's going to be a small o, and if it's go to infinity, it's going to be big O. Does it make sense? Okay, and then we have a really, really important like graph. So let me show that graph too. So we have a really important diagram. So we say, let's consider this one. Let's consider this point. This is going to be a small o of g of n. As you can see, when I talk about the small g of n, we remember here. Like here. Yeah, when I talk about the small, I say this is going to be subset because, as I explained, because this one has equal, the other one doesn't have. So it means a smaller O of Gn is inside the big because there is one like equal that we don't have. The definition, just one of them has equal, the other doesn't have. So a small O of G of n is going to be inside the big. So, and then I talk about intersection. Let's talk about a small omega n. A small omega n doesn't have that equal either. So it's going to be inside of the big omega n. And as I explained earlier, if you have the intersection between big omega and big O, so this is going to be theta. This is where theta of G of n. As I explained, because it's going to be between. So this is the definition. So a small omega G of n is going to be inside the big O of G of n. A small omega G of n is going to be inside of the big omega G of n. And the intersection between omega, big omega and big O is going to be theta of G of n. Does it make sense? Is it clear? Okay. Okay, sounds good. Does anybody have any question? So if you don't have any question, probably so we are done with today's session. So if you have any question, I would be happy to respond. So yeah, we are gonna keep working on finishing this notation tomorrow. No, there is no quiz tomorrow. There is a quiz on, tomorrow is Thursday actually. Yeah, there's gonna be a quiz, yes. So attendees, for example, you have a quiz today, so it's part of attendees too. So tomorrow you are gonna have a quiz. As I'm gonna post this note, just look at this note, and then we will have one, for example, really simple example that is this a big O of G of n or is it not? So you can do this like we division and just get limit, and so figure it out. Is it gonna be equal to 0? Is it gonna be infinity? So that's gonna be, yes, that's gonna be probably it's gonna be the question with for choice, that is gonna be big omega, a small omega, big O notation, a small equal notation. You need to choose, but you need
How many questions?
probably 2. But you
And
need,
is it based off everything we've learned this week?
yeah, everything we learn this week. Probably most of them is big O notation. There's nothing else. You can big O notation, a small O notation, big omega, and a small omega. So everything that we teach, I post. There's a PowerPoint that I post this morning. So probably you saw that one in Canvas, and I'm gonna post this one too.
And you
Great.
said it's going to be multiple choice, right?
Multiple choice, yes. But you need to just know how to calculate them. It's not that you just choose one of them. You need to know how to do it. So probably you need to learn, just read this one again. So does it make sense?
Yep. Thank you, Professor.
You're welcome. So I don't know. I will decide, maybe it depends. I will choose the question. So probably it's going to be the beginning of the class or end of the class. I don't know. I will decide. I don't have something in back of my mind right now. Does anybody have any other question, or we are good?
You know how many questions?
What?
Do you know how many questions?
It's probably going to be 2.
Okay. And the same as like today?
Yeah, like exact same things. It's going to be multiple choices, but you need to know about big O notation, all of this big O notation.
Okay, thank you.
Yeah, you're welcome.
Have a good day.
And you guys too. So have a good
Have a wonderful night.